We are beginning a new unit. This unit is on linear equations. As we begin this unit, I want you to understand that much of the material in this unit will be new to you. It will stretch you to think in different ways than you've been asked to think before. I want you to understand that as we begin this first lesson, we're going to cover some important vocabulary words. And probably most, if not all, of these vocabulary words will be new to you. So as we go over them, it may seem difficult to you, and that's okay. I want to remind you that you have the ability to rewind and hear me explain a word again. I want to remind you that you have the ability to come back to the lesson and hear me talk about this important vocabulary as many times as you need to. Resist that urge to become frustrated because it seems difficult or it seems hard to you. Remember, anytime we learn something new, the first time we hear it, it may be challenging. But the more and more we hear it, and the more and more we discuss it, it will get easier as we go. I also want to let you know that in this lesson, in this unit, we will be requiring many more teacher-led sessions. So please also keep that in mind, that if you have questions as you listen, maybe jot them down and bring them to the teacher-led session the next day. Okay, let's begin looking at our new vocabulary words. Our first word is relation, and a relation is a set of ordered pairs. Now, ordered pairs is probably familiar to you. Ordered pairs is what we get when we graph. So here's a graph, and let's say I give you the ordered pair. Let's do the ordered pair 2, 3. Okay, well, we can plot that ordered pair on a graph. We would go over to 2 on the x-axis and up to 3 on the y-axis, and that would be the ordered pair 2, 3. Well, a relation is a set or a group of these ordered pairs, okay? And we may see these ordered pairs written just like this in traditional form, but we also may see them written in a chart or a list form as inputs and outputs. Okay, so a relation is a group of these ordered pairs. Word number 2, input. Input means what we put into a function or the x-coordinate in an ordered pair. So let's go back to the familiar, an ordered pair, okay? Whatever we put in for x in the ordered pair is called our input. So in the ordered pair example I used above, 2, 3, 2 is the input value, okay? Number 3, output. The output is what comes out of a function or the y-coordinate in an ordered pair. So when I have an ordered pair, the y-coordinate is called the output. So in our example from above, the 3 in that ordered pair is our output value. Okay? So we have relations, a set or a group of ordered pairs. And in every ordered pair, we have an x and a y coordinate. But we can also refer to that as an input and an output. Okay? Number 4, domain. Domain refers to all the possible input values or the x-coordinates. So if I have a relation, if I have a group of ordered pairs, let's say I have an ordered pair 2, 3, 4, 6, and 6, 9. Okay, let's say that's my group of ordered pairs. The domain are all of my input values. So 2, 4, and 6. All my x values, remember another name for that is input. All of those are my domain. So I would say the domain is 2, 4, and 6. Okay, our next word is range. Range is all possible output values or the y-coordinates. So in that relation, I just use an example, 2, 3, 4, 6, and 6, 9. My range are all the y values, 3, 6, and 9. So I would say the range is 3, 6, and 9. Okay? And then finally, our last word here is function. A function is a set of ordered pairs. Okay, so a relation. It's this group of ordered pairs that we set up above we could call a relation. A function is a set of ordered pairs where each input has only one output. So another way to say that is each x value has one y value. So 2 has an output of 3. Okay? You may say, well, of course, every ordered pair has two numbers. It has an x and a y. But what we're getting at here is that 2 has an output value of 3. It only has one output. We wouldn't have an output that says 2. So we wouldn't have 2, 4, in other words. We wouldn't have the same input used again with a different output. We have an input that has one output, so 2, 3. Okay, we're not going to repeat the input again and get another output like 2, 4. Okay, that would mean for the input 2 that it has two different outputs. That's not the case. A function is a set of ordered pairs where each input has only one output. So let's look at a graph, something we are familiar with, and talk about some of that vocabulary in relationship to this graph. Okay? Here we have an ordered pair. We have an input and an output value. Okay? Our input value is the same as x. So we go on the x-axis to 2, we go on the y-axis up to 3, and that's the ordered pair 2, 3. We had an input and an output value, and that led us to this location on the graph. Here's another ordered pair, -1, 4. We have an input and an output, -1, 4. Our input and output lead us to this specific location on a graph. Okay? We could say that this is a relation. It's a set of ordered pairs. Each input has one output. Okay? And none of the for each input there's one output. 2 goes with 3 and -1 goes with 4. Okay? So, ordered pairs, what we're familiar with. Let's relate that to these new words. An ordered pair has an x and a y. The x can be referred to as the input. The y can be referred to as the output. We said that domain describes all the x values. So another word for an x value is the domain. And the range describes all the output values. So another word for the y coordinate is range. Okay, so think about this. Of those 6 vocabulary words, 5 of them we can relate to something we understand very much. 5 of those words centered around the idea of ordered pairs, x and y coordinates. Okay? A relation is when I have a set of these ordered pairs. And input is the same thing as the x value, and output is the same thing as the y value. Domain is the x values, and range is the y values. So even though these words may sound a little strange to you, they're closely related to something that you're probably pretty familiar with. Now, I said to you earlier when we talked about relations that a relation is a set of ordered pairs, and we might write them very traditional. This is very traditional, right? You all are used to seeing ordered pairs written this way. But we might also take those traditional ordered pairs and we might put them into a chart. Okay? Notice I have the same, I started with -2, 1 over here. I have -2, 1 here. Instead of it being written as an ordered pair, it's written in an input and an output table. Remember that an input is just simply the first number in an ordered pair. And an output is simply the second number. So -2 is the input, 1 is the output. -1 is the input, 2 is the output. It's just another way to write ordered pairs. So we might see these ordered pairs written very traditionally, but we might also see them in chart form. Okay, so let's just check our understanding of that vocabulary. Okay, we're going to decide which of these examples are functions and which are not. So let's take a look at our first input-output table. Remember, here's our x coordinates and our y coordinates in the ordered pairs. In order for this relation, this set of ordered pairs to be a function, each input must have only one output. 7 has an output of 19. 9 has an output of 23. 11, 24. 13, 19, 15, and 33. So each input had an output. I didn't hear anything repeated. So this is an example of a function. Okay, let's look at our second input-output table. Negative 11 has an output of 1. Negative 8 has an output of 8. Negative 8 is used again with an output of 4. So for the input negative 8, there is more than one output. It has an output of 4 and it also has an output of 8. That means this is not a function. The input of negative 8 has more than one output, so it is not a function. Now, let's look at these relations written more traditionally. Here's a list of ordered pairs, okay? Here's our x coordinate and our y coordinate, our x and our y, our x and our y. So let's check the inputs. We have an input of negative 2 and an output of 4. An input of negative 1 and an output of 1. Input of 0, output of 0. Input 1, output 1. Input 2, output 4. None of the inputs repeated. Each of them just had one output. So this is an example of a function. Let's look at the last example. We have an input of 2 and an output of 7. We have an input of negative 1 and an output of 3. We have an input of 2 again, right? We had 2 here. Now we have 2 again. Okay, notice that here we got an output of 7 and here we got an output of 12. Each input can only have one output. 2 cannot have an output of 7 and an output of 12 if it's a function. So this one is not a function. Okay. So listen as often as you need to those vocabulary words just to familiarize yourself with them. I'm going to ask you to submit your notes when you finish to Seesaw, and then there's another short video that I want you to watch to begin to develop your understanding of what a function is.